Hello friends, welcome to Rajavali Education channel. In this video, we are going to see construction, diagram and the working of moving coil galvanometer. First, we see what is the principle involved in a moving coil galvanometer. The principle is when a current carrying loop is placed in a uniform magnetic field, it experiences a torque. A moving coil galvanometer consists of a rectangular coil of PQRS of insulated thin copper wire. The coil contains a large number of turns wound over a light metallic frame. A cylindrical soft iron core is placed symmetrically inside the coil, which increases the strength of the magnetic field. The rectangular coil placed between two pole pieces of a horseshoe magnet. Next, pivot is directly attached to the coil. Pivot is used to free rotation of the coil. Next, the spring is attached to the coil. The spring is used to create the counter torque. Next, deflection needle is connected to the coil. Positive terminal of the battery is connected to one terminal of the rectangular coil and negative terminal is connected to other terminal of the rectangular coil. Now the whole part is closed. Here you can see the measuring scale. If no deflection in the coil, the galvanometer points to 0. If there is movement in the coil, there will be a deflection in the coil. The deflection side depends upon the direction of the flow of current in the coil. As soon as the switch is on, the current flow in the coil. Now you can see the current is entering into the coil. On PS side, the current direction is parallel to the magnetic field direction, so there will be no force. Next, the current will move from P to Q. Here, flow of direction of current is perpendicular to magnetic field direction. So force will be created on the coil according to Fleming left-hand rule. If we keep middle finger as the direction of the current and forefinger as the direction of the magnetic field, then thumb shows the direction of the force. Here you can see the thumb finger is a downward direction, so the coil moves to downward direction. The needle of the galvanometer moves to left side. Now current flow from Q to R. Here direction of the current is parallel to magnetic field direction, so no force will be created. Next, current flows from R to S. Here, the direction of the current is perpendicular to magnetic field direction. So, according to Fleming's left-hand rule, thumb shows force direction. Here you can see the thumb finger is upward direction. So, the coil will move upward direction. The galvanometer needle deflects to right side. Due to this deflecting torque, the coil gets twisted and restoring torque is produced on the spring. This is known as restoring couple. The amount of the restoring couple is directly proportional to the amount of the angle twisted, that is phi. Torque is directly proportional to pi. To remove this proportionality, we can introduce a constant K, where K is known as torsional constant of the spring, that is the restoring torque per unit twist. Here we consider the single turn of coil, that is PQRS. In PQ direction, the force is in downward direction. During RS direction, the force is in an upward direction. On two sides, the forces are in opposite direction. So torque can be calculated by distance into force, where distance is equal to B, that is the distance of PS. Force, we know that force is B into I into L into sine theta. Here theta value is 90 degrees, so sine 90 is equal to 1. So force is equal to B into I into L. If we combine L into B, we get area. So torque equal to area into B into I, where B is the magnetic field strength, I is the current, A is the area value. Tau is equal to A into B into I. This value is for only one term. If we have number of n terms, we get tau is equal to n into I into A into B. We know that tau is equal to k into pi. Introducing torque value here, we get NAVI equal to k pi. If we want to pi, bringing this k value to right side, we get I into NAB divided by k equal to pi. Number of turns, area, magnetic field strength and the k values are constant. So I is directly proportional to pi. The deflection pi is indicated on the scale by pointer attached to the spring.